Topic 4-3, parallel lines in algebra. We're going to be doing some algebra equations for this one. Can be referenced in Chapter 3, Section 2, page 155 through 169 in the whole textbook. Through our parallel line investigation, we learned that when parallel lines are cut by a transversal, which pairs of angles are congruent? We've got lots of them to think about. 1, corresponding angles. 2, alternate interior angles. 3, alternate exterior angles. And then the ones that are supplementary, meaning equal to 180 degrees, would be the same side interiors and the same side exteriors. You remember when we traced these. So these are the ones that would be congruent. We're showing congruency. One way of showing congruency is with this symbol right here. Okay, next question. Which angle pairs was always congruent regardless of whether the lines were parallel? We learned that when we were shown examples, figures 1 and 2, where one was a set of parallel lines and the other one was not. Vertical angles were always congruent. There was also a pair of angles that were always supplementary regardless of whether the lines are parallel. Those were called linear pairs. So this example, tell what type of angle pairs each is and tell whether they are congruent or supplementary. 1 and 3. I'm using 2 pencils. Again, these denote parallel lines. So you can take a highlighter and mark your transversal. Sometimes this helps. If this is the line that cuts them in half, you might want to note that this is your transversal. And 1 and 3, which are here and here, if I took my patty paper, I could trace them. Those are going to be corresponding. They would actually be congruent. Angles 3 and here, they're on the inside, the interior of these two vertical angles, and they jump over. They're alternate across the transversal. That's why they're alternate interior. So those would also be congruent. 4 and 5 are alternate exterior. You've got one up here, one out here. They cross over the transversal, and they're also on the exterior of the two parallel lines. So 5 and 4 are exterior. If it helps, let's do one more and then I'll explain. 2 and 3. 2 and 3 are both, this is what I was going to say, if it helps, shade the interior with a color. Maybe put interior. And then take the green, or any color. The green is going to denote exterior. So this is exterior, and this is on the exterior. Sometimes this helps if you're looking at what's happening when we alternate between going across the transversal. Same side, 2 and 3, slide this up a little slightly. Interior or supplementary. They equal to 180 degrees. They make up a linear pair when you add them together, but notice they're both in the orange area, which is the interior, but they did not cross the transversal line highlighted. Take a minute to get that understood. 1 and 6, again, if I measured it, would be exactly congruent, and they are across from each other. They're vertical angles. And the last one on this page, 1 and 4. 1 and 4, notice they're both in the green. So those are same side. They didn't jump over this yellow transversal line. Same side, and we've learned that same sides exterior or same side interior would equal 180 degrees. They would make up a linear pair. And again, I'm not going to actually trace it again, but just know that if you can form with two angles a straight angle, this makes 180 degrees. If you want to add this to your notes somewhere on this page, that would be a good idea. This angle with this angle, if it makes a straight angle, it's always supplementary, 180 degrees. Okay, let's do some algebra problems. The first example. For each of the examples below, identify the type of angle pair, and given that the lines L and M, I think that's an M, are parallel, find the values of x. So if it's a given that they're parallel, you can denote that using lines. Again, if it helps to color code your interiors and exteriors to know whether they're congruent or not, alternating, that's what it looks like. All these examples 2 and 3 are alternate interior angles, and these two are on the same side of the transversal. Again, you can highlight your transversals. Those would be these lines crossing through the parallel line L and M. Okay, so let's work this first one. If we know that they're alternate interior, go ahead and write this here. I better use a pen. See it a little bit better. Alternate interior. What that means is that those two angles are congruent. If they're congruent, then they are equal. So setting them equal to each other, you have 2x minus 10 is equal to 3x minus 40. You can subtract the 2x on both sides. That goes away, leaving a negative 10 is equal to x minus 40. You want your constants on both sides, so we'll add 40 to both sides. Those cross out, so now your x is equal to 30. Kind of run out of room to show it straight down. Usually you want to carry your line straight down if you've got room. So 30 is the value of x. Now that's not, they only asked to find the value of x, but had they wanted to know the angle measurement, denoted with this little circle, you would have to fill in that 30, multiply it by 3, and subtract 40. But in this particular problem, they're just asking for these next examples the value of x. So for example 3, you're going to put those set equal to each other again. Let's do one more. 4x minus 30 is equal to 2x minus 14. Oh, I think because that one's the same as that one, so they made up a different problem and I forgot to put them in here. Sorry. We're going to make this 4x minus 30 and this one 2x minus 14. Two new problems because it ended up typing up the same. I'll fix that. Alright, so if you subtract 2x from both sides, those go away. Sometimes it's good to put a line under here so that you know your addition, it's not division. This is going to be a positive 2x minus 30 is equal to a negative 14. You want the 2x by itself, so you're going to add 30 to both sides. These would go away. I'm writing too big. You have 2x would be equal to 16. Divide by 2 on both sides so that x is equal to 8. Put that answer over here. And these are, if I put them in the same place, that they are alternate, same thing, alternate interior. A little bit of problem with that one. Okay, be careful with this one. Same side interior is the type of angle pair. So we have to remember that adding these two together is going to give you the setting them equal to 180 is the way we would solve that. So you've got 5 and x, which would be 6x. 6x minus 24 is equal to 180. You add 24 to both sides, which is going to have these go away, which will give you 6x is equal to 204 when you combine those. Divide by 6 on both sides so that x would be equal to 34. So you can put that on this line right here, 34. Okay, last two more examples. This one's shown in an interesting way, but it's still telling you that L and M were your parallel lines. So your parallel lines are over here. So if you were in the habit of tracing with the highlighter your transversal line, this one would be the transversal. We'll go ahead and do this one too. If these arrows denote parallel lines, and so is that, and there's a line that cuts them in half, then the transversal line is going to be that one right there. So it might be a good idea to go ahead and highlight the transversals to help you name the angle pair. Okay, so for this one, they're wanting to know which ones they would be. So we're looking at, let's just draw this parallel line a little bit extended. If you have this line extended out to here, you might want to do this on your paper too. Maybe put it as a dotted line because it's not really there. You know that this one and this one would be the same side interior. Look closely. This angle and this angle would be the same side interior. Well, what are you trying to solve for is x. Two lines opposite are, you might go ahead and note this. Let's write this. These are vertical. So the type of pair, angle pair that this is really none, because same side here, but then this is vertical. There's no relation between an interior and an exterior being congruent or an angle pair because it's not shown to be right here. So I can't call it a same side. I can't call it a linear pair because it's not sitting next to it. So really the type of pair this is none, because they're not, they do form 180 degrees, but it's not necessarily any pair that we could name. So since we know that all of them equal 180, you've got 3x minus the 40 plus the x, don't forget this one, is all equal to 180. Combine your like terms. 4x is minus the 40 equal to 180. Add 40 to both sides, you get 220 is equal to your 4x. Divide by 4 and you get 55. Only x is equal to 55. It's not the degree angle. You would have to substitute it in for x, multiply by 3, and subtract 40 for that. Pause if you need to, but let's move on. This one's asking you to find the values of x, y, and z. So there's quite a few things that we can look at here. If we want to take some of our colored pencils and mark some congruent angles, they would be this one, doing this with orange, hop over, and this one, alternate interior. We're not asked to name the pair of angles for these, but we are just solving for these variables. This is parallel to this one, so that is going to be congruent to that. Let's do that one with a green. I'm going to mark it with another little tick mark just to show the difference. This one is with that one. Okay, so we're trying to solve for a variable. Notice this is kind of like a puzzle. The one you would want to look at first is the one that has only one variable. If I set this equal to this, I'm going to have two variables. But the orange, I have the 18 and the 2y. So 2 times y is equal to 18. Divide by 2, my y would be equal to 9. Alright, so if y is equal to 9, then I could actually put that this is actually 18 degrees also. Okay, if you've got 63 here, I know that we haven't gone over this, but parallelograms have supplementary angles here and here. We have kind of gone over that when we traced it with patty paper. If I traced this with patty paper and lined it up right here, I want you to be able to see that. Let's just kind of color this in. That if I put that here and I do a straight line here, what is this going to create? A linear pair. Not sure it's easily seen, but this plus this is equal to 180. So if you have, and I think I'll just go back to my pen. If you've got 63 plus the 18 plus the 11z, all of that would be equal to 180. Notice I'm looking for a single variable in my equation. So 81 plus 11z is equal to 180. 11z is equal to 99. When you subtract 81, divide, you get 9. So if z is 9, then this angle measurement would be 11 times 9, which is 99. So if I needed to find the value, we still haven't gotten the value. We've gotten the value of y and z, and now you need the one for x. Well, if you know that 3x is supposed to be equal to 99, you've got 3x is equal to 99, so x would be equal to 33. Fill in your blanks, 33, 9, and 9. And again, remember, we only substituted the z in for here in order to get our two green ones lined up to make this a shorter problem. That it's the 3x was the same as 11z, but if z was 9, we multiply by 11, we got 99. So again, pause this, study it. You'll probably have some problems like this on the worksheet. And that concludes 4-3.